Hi, welcome to your lesson on quadratic functions. Very big topic in mathematics, but also considered a prior learning topic in this course. So we're going to look at a lot of material in this single lesson video here. So pay close attention and pause when you need to. Alright, what are quadratics? In mathematics, quadratics is a type of problem that deals with a variable multiplied by itself, an operation known as squaring. This language derives from the area of a square being its side length multiplied by itself. The word quadratic comes from quadratum, the Latin word for square. So when we think about squaring something, that's a quadratic. So these are quadratic expressions. Quadratics in algebra are expressions or equations that have a highest power of 2 or a square. So here we see x squared. Here we see x squared again. Here's w squared, m squared, y squared. These are all quadratics. The highest power is a square. These are not quadratics. Take a look and see why. Okay, quadratics are important in many ways, but one of the main ways is that they can be used to model the trajectories or flight paths of objects in our atmosphere. Most objects will fly in a parabolic path due to gravity. When we talk about that path, that shape when graphed is called a parabola. Here's an example of a parabola. It will always have x-intercepts, it will always have a y-intercept, and it will have something called a vertex, or the turning point. There is an axis of symmetry that passes through the vertex, and it makes the parabola symmetrical on either side of it. This parabola opens up, so the vertex is a minimum point, and this kind of parabola is also called concave up, because it opens up. Alright, here we have a concave down parabola. It still has a vertex, which is now a maximum. It has two x-intercepts, it has a y-intercept, and a line of symmetry. Alright, the simplest way to sketch a parabola is to just take the equation, substitute values of x into it, and see what y values we get. So for example here, putting these x values, we can create a table of values, plot the points, and get a parabola. However, in this lesson we're going to look at more detailed ways to graph, not just plotting a bunch of points. But if we do plot like that, we still end up with this parabola with x-intercepts, a turning point, a y-intercept, and so on. So those are our key points on a parabola. Okay. Sketching in IB courses, though, requires you to be able to use your calculator often and then transfer what you see on your calculator to your page. So we're going to try one here. We're going to put that one in our calculator, and then we're going to draw it and give the domain and range of it as well. Okay, so in the IB world, sketching often means drawing a sketch. It doesn't have to be a super detailed graph, but drawing a pretty detailed one that has key points. So we're going to focus on the key points like x and y intercept, vertex, and so on. Let's take a look. I've already entered in my calculator. I hope you have as well. There's my equation. I've set the window, so you might have to reset the window, but I set the window to be, I think, up to 17 on the x and up to 15 on the y. So there's my parabola. I can easily take that diagram and sketch it on paper now. However, let's get some key points. How could you get, for example, well, the domain is really important here. So it says from 2 to 14. So when I sketch it, I should only draw from x equals 2 to x equals 14. So on the calculator, one thing you should be doing is this. You can definitely use second calc, and in there you can find maximum minimum, which is like your vertex. So in this case, we'll look for the maximum vertex, the zeros, which are your x-intercepts, and you can also do number 1, which is value. Let me show you what that does. Number 1. You can put in an x value, it will tell you the y value. Since it wants us to draw this graph on a domain of 2 to 14, I want to see what happens when x is 2. So when x is 2, y is negative 5. So that'll help me draw it properly because it tells me there's a starting point of 2, negative 5. And then look at the ending point, 14. So I'm going to put 14 on there. So again, second calc, number 1 for value, and I'm going to put 14 in there now. And now I see y is negative 11. So it kind of tells me where to start and end my graph. So let's take a look. Here's my graph. So here's that point 2, negative 5 that I found. And the domain starts there, so the parabola is cut off there, and then it goes to there, 12, and I see, 14, negative 11. So there's the other point we found. So there's that graph, and these x-intercepts and vertex could be found on your calculator as well. So there's the domain, and there's the range of that parabola. Make sure you know how to sketch that, and make sure you understand when it gives you a domain restriction like that. Okay, let's keep going. So we're going to talk about quadratic functions in 3 forms. This is standard form, or general form. This is called a vertex form like this, and a third common form is called intercept form, looks like this. They are all quadratics, different forms, but different forms are useful at different times. Let's begin, and basically you can change from one form to another, and there's all kinds of ways to do that. So we'll take a look at some of that in this presentation. So first, let's look at vertex form. To begin with vertex form, we are going to talk about transformations. So here's a parent quadratic. We know it sits with a vertex right here. So where is the vertex? All right, hopefully you can see, obviously, vertex is 0, 0. So what happens when you transform it? We learned transformations in a recent lesson, and we know that this shifts a graph and this shifts the graph as well. So where would the vertex be now if you had this child function and you had these two translations occur right here? Where's the new vertex? Well, hopefully you noted the vertex will be at 2, 4, because this tells you the graph shifts 2 to the right and here 4 up. So if this vertex went 2 right, 4 up, we would have the vertex here. So now this tells you a little bit about vertex form. This form looks exactly like we have here. So why do you think it's called vertex form? Because the vertex is plainly obvious in this form of a quadratic. We can see this value and this value make the vertex, except for this value needs to be the opposite. It's not -2, it's +2. So the vertex is very obvious there. Let's investigate that a little further in Desmos. I have an equation in vertex form, and I have a, h, and k, those three values being sliders. Let's look at when, right now, h and k are both 0, so my vertex is 0, 0. However, if I move the h, I'm making the h value positive, but in that equation it will be negative because there's a negative there, and notice the vertex has moved. I'm going to move the k as well, so I'm now moving k up. So now my h is 2.3, k is 4.2, so that's my vertex. So h and k represent the vertex. We saw that in that last example. So now I make h negative, and our vertex moves, right? So the h value is the x value of the vertex, the k value is the y value of the vertex. So remember that and take a look at these values again compared to this. Now, one thing you should know is that we have an axis of symmetry, right? There's the axis of symmetry. It passes through the vertex, and it will be the x value. So the equation of that will be x equals 5.7. And as I move the h value, it changes where my axis of symmetry is. So here, my x value is 3, so the axis of symmetry is x equals 3. And again, when h is 3, we actually see -3 in here. All right, here's the basic parabola. Let's take a look at how our parabola compares to that one. I'm going to move this one back to here, and I'm going to move it down again, back to the original position. Okay, notice what happens when I change a, because this is also important. As I make a bigger, my parabola gets narrower than the original parent x squared graph. All right, as I make a smaller, it gets wider. When a is 1, I have the same as my general x squared parabola, which I had here, x squared, but as my a gets to be a decimal value, the parabola gets wider. So this is important to know. A is big, parabola is narrow. A is a fraction or decimal between 0 and 1, it's a wide parabola. And then when a is negative, it's a downward facing parabola, so concave down. So when a is negative, concave down. So things you should definitely know about parabolas. Let's continue here. So looking at this one here, our job is to say what are the a, h, and k values. So here we can see a value of 2. We see an h value. Remember, it's the opposite of what we see here, so -1, and k value, -4. So this parabola will open up or down. Well, it's up because we see a value is positive. Where's the axis of symmetry for this one? X equals -1. Remember, the h value tells us the axis of symmetry, so the axis of symmetry is -1. And the vertex, well, we see it in here, the vertex form, so -1, -4 is our vertex. Try the same thing for the second one. Okay, there's our a, h, and k, opens down, -a value. Axis of symmetry is the h value, which is 2, and vertex is hk, 2, 5. Try the last one. Okay, check your work here. Great, let's summarize. Quadratics in this form are called vertex form. Vertex is at hk, and the axis of symmetry has an equation of x equals h. So try these two problems here. You are to find the axis of symmetry and the vertex of each. And now check your work for both. Great. Let's talk about another form, or let's talk about how we change from vertex to standard form. So how would we change from here to here? So here's our focus on standard form, vertex to standard form. If we are given these vertex form ones, which are the ones we were just looking at, and we want to change to standard form, we can take that and we can just actually, well, first of all, let's note that the vertex is -1, -4, right? We know that from vertex form. And now to change it to standard form, we're going to take that x plus 1, expand it, multiply all that, combine some things, multiply by 2, and then combine the 2 and the -4 to get that. So please pause if you need to check those steps carefully. But basically, to change that to standard form, we just expanded and combined things. Now this is called standard form. Try something. In standard form, try doing -b over 2a. So negative this value divided by this value. What do you get and what do you notice? Okay, when we do -b over 2a, it gives us -1. And notice that that is the same value as the x value of the vertex. So this little formula can be used in standard form to find the axis of symmetry or the x value of the vertex. And then, of course, we can take that value, which I've written in this form, put it into the function. So it's like saying that -1 goes into the function, and we can get the y value. And in this case, if we put -1 into this function, we get -4, and we can see confirmation that that matches the vertex we saw from vertex form. So let's look at standard form in decimals as well. So here's standard form. You can see standard form right here, A, B, and C values. So again, A, we learned what A does before. A expands it when we make it a decimal value. It makes it concave down when A is negative, or when A becomes a large value, it becomes very narrow. So it's the same thing we saw A doing in the other one. A always has the same effect. Okay, now let's look at what happens when you change C. Okay, it moved up. B, it's moving in an interesting way when I move B. Okay, so there's B. Okay, now look at the parabola. I have the y-intercept marked on here. Check what happens when I move the parabola up and down. C is moving it up and down, but C value, the C value of 2.8 here, matches the y-intercept value right here, 2.8. So let me go up a little bit. C value of 4.6. It's the y-intercept. So the C is always going to be our y-intercept value. You should remember that for sure. So C value in standard form, always our y-intercept. And notice here I put in a point, -b over 2a. That's the formula we just saw that gives us the vertex. And notice here we have the vertex. So 1.5, -2.65. So as I move it around, that -b over 2a always gives me the vertex location. Okay, so that's standard form parabola. C value is important to know for sure. Okay, let's keep going. So if you notice when we change the B value, it's something interesting when it was happening, and this is what is happening. As you change the B value, the parabola's vertex travels on a path of a reflected parabola, like that. So there's a lot more mathematics behind the scenes there, but let's just leave it at that for now. If you want to research that more, I would recommend doing that for sure. All right, let's summarize. We have a standard form equation like that. So standard or general form is the name for that. The equation for the axis of symmetry is -b over 2a. We figured that out. The coordinates of the vertex are, well, the axis of symmetry, x value, and that value put into the function. So it gives us the vertex. And the y-intercept is 0c. The c value gave us the vertex. Sorry, the y-intercept. So with that knowledge, try these two questions. In this one, it's asking you to take the standard form and find, let's see, so find a point of symmetry. So anyway, it wants you to find the y-intercept, the vertex, and then graph it using that information. Okay, check your first one. Finding the axis of symmetry, and then the vertex using that value. Finding the y-intercept, and then it said something about finding a point that's symmetrical. So if you know the y-intercept and you know the axis of symmetry, you know that there'll be another point that's the same distance away over here. So the axis of symmetry is at 3, so that means the vertex was 3 away from that. So there will be another point that's 3 units away in this direction, which is this point. And having that third point helps you draw a better parabola. So try that with B, that same process. Try that now. Okay, check your work here. So again, finding the axis of symmetry, using that value, putting it into the function to find the vertex, then the y-intercept, and then a point symmetrical to that across the axis. All of that helps us draw a better sketch. And remember, when we're sketching in the IB world, you need to label some key points. And in this case, we have a vertex, y-intercept labeled. That's good. Great. In the next video, there's a second follow-up video. We're going to look in more detail on the third form of quadratics. So please watch that video now.